Yeah, good morning, everybody. Thanks very much for your time in joining us for the webinar this morning. As you know, we'll be covering a case study and describing a case study to you about a deployment of our Omnia QM and Omnia MA solutions. And those are technologies that are able to generate and optimize CDR metadata, and also actually be able to measure the performance of a number of network components such as base stations and so on. My name is Paul Brett. I'm responsible for Cubro's business in the UK, Ireland, and the Middle East, and I'm your host today. And I'm joined by Lucas Ettlinger, who is a solutions engineer and a member of our technical team based in Vienna. Lucas actually will be covering the majority of the agenda. I'll just start briefly in a second, just give you a little bit of background about the business challenges and of this particular customer, and the benefits and the value that they derive from the solution that we delivered for them. I'll then hand over to Lucas, who'll go through the detail of the technical challenges, the solution itself, how we deployed the solution, and also what the outcome was of a number of the use cases that the customer was able to operationalize from the deployment of our technology. I'll then summarize again at the end, and we'll move on to a Q&A session. I should mention, obviously, if you have any questions as we go through, then please just raise those questions in the chat box, and we can answer those as we go, or we can wait till the end and answer them then, whichever you prefer. We'll also have a number of polls, and we certainly appreciate your feedback and response to those, and we'll have some handouts as well that you'll be able to download. So I'll start then with just a brief couple of slides, which will just give you a little bit of background and context about this particular customer. They are one of the major European mobile network operators, and this solution has been deployed in operation there for just over 12 months now. Actually, their high-level challenge was that they wanted to find a way of mitigating the rate at which they had to continually invest in monitoring technology and monitoring solutions in line with the rate of growth of the traffic across their network. So in other words, they wanted to find a way to reduce the amount of a budget they were having to spend on monitoring solutions as their network grows. They had some very specific business challenges that had associated operational challenges as well, as a whole part of that. And they're the usual suspects, where they wanted to obviously increase revenue, reduce customer churn, so try to increase market share, address some of the specifically challenging cost areas. One of those is the cost of ownership of their monitoring solutions, but also, as we've all seen, actually, the increasing costs of power and in rates of inflation over the last couple of years. They had a couple of very specific operational challenges that they needed to address, and one of those is a regulatory compliance, and in this environment specifically around GDPR, and also the migration to new technologies. And again, specifically with this customer, they were looking to migrate to 5G standalone technology. And as I say, that came with a number of associated operational challenges. Obviously, in this environment, they're operating in a very demanding marketplace and environment, and with customers that have very high expectations in terms of service level and network performance. So they need to be able to deliver high level, excellent level customer service, and be able to, wherever possible, proactively identify problems and resolve them before the customers are aware there's been a problem. They're also working with very complex network architectures, typically with multiple technologies that are delivering and supporting multiple use cases, but the need to be able to manage those technologies and that environment as a single entity wherever that's possible. And of course, allied to that, then that ongoing increase, a massive increase in the growth of traffic volume, which is pushing that complexity and again further pushing the cost of monitoring the user plane traffic. They're a very specific operational challenge to be able to mask personally identifiable information related to GDPR compliance, and as I mentioned, the intention to migrate to 5G standalone. So, for those that know Cubro, you would be aware that we have a whole range of out-of-the-box, off-the-shelf technology and products that support network visibility solutions from very low-speed copper environments through to very high-speed fiber environments. But we also have the ability as a company to be able to tailor those solutions and in some instances develop new capabilities for customers as well. And actually this case study is an example of that capability. So what we did was develop a new capability specifically for this customer, which, as I mentioned previously, was to generate CDR metadata, optimize that metadata, so reduce the quantity of that metadata that's exported to their monitoring systems, but retaining all of the necessary intelligence to allow those monitoring systems to carry out their function. And of course, it goes without saying, we met all of their requirements by delivering that capability. If I summarize what that solution delivered, it was to, again, generate metadata across multiple technology domains in their mobile environment. We were able to optimize that metadata, so we were able to reduce the quantity of the metadata before it's exported to the monitoring systems, but retain all of the intelligence required. In fact, we've measured that reduction up of a factor of up to 1,000 times compared to raw network traffic, which obviously has a significant impact on the sizing and capacity requirements for the monitoring solutions, and therefore an ongoing impact into the CapEx and OpEx of those monitoring solutions as well. And that sort of brings us to our next point, because the advantage of that was able to mitigate that relationship between the cost and the spend on monitoring solutions as the network traffic grows. And of course, because it was a design that we undertook, we were able to deliver a solution with a very small footprint, and typically less than 50% compared to other alternative approaches. So we were able to deliver a solution that used less space, therefore use less cooling, and therefore use less power as well. And finally, we were able to help them with their regulatory compliance and specifically with their GDPR requirements as well. So that's it from me in terms of just providing some context around the background to this customer's requirements. I'll hand over to Lucas that will take you through the detail now, and I'll come back and summarize at the end. So Lucas.
Thank you very much for the introduction. And I will bring up my slides that you should see, and then I will run you through this project on what was the, as said, Paul, the challenges and how we have been overcoming all these challenges. Let's start. But all the inputs you already got from Paul. So on what we will be handling today, like what are the challenges? How could we customize, or how did we customize our solution, and what are the technical benefits of using our solution compared to others? So the customer requirement, to start with that, actually was kind of straightforward or not. I mean, depends always on how you see it. The customer was dealing with complaints about the network speed, and then they needed some solution to verify, are these complaints somehow correct or not? Because of course, this is always a thing. Everyone feels it a bit different. Was my network speed that I got okay or not? So they needed somehow a mechanism to check what was really the actual customer experience at the time the customer complained about it. So this is the key thing that they want to do. Just to give you some background, this customer, they have like 2 data centers. Each one has like 24 times 100 G links and a total bandwidth of 1 terabit of user plane traffic. What we in the end delivered is like a metadata record, which is per subscriber, per service, and the consumed data for this subscriber in a period of a minute. Going on to the challenges, and this is where it gets, of course, interesting, is with the current solution that the customer had, because they already had something deployed, and this solution is what we replaced, is they had a really high volume in terms of metadata generated, And this, of course, in the end also generated high costs in terms of storing all of this information and processing this information. So this was the first point our solution needed to make better than the old one. Then also these days, terms of rack space is also something that is important. And also this we could reduce, and also the consumed power, also this we could reduce compared to the old one. Then they had recently deployed, before starting the project, a 5G standalone core. So that means our solution also needs to handle the 5G standalone core traffic. Also that is something we implemented and is running here at this customer. And then coming to the last 2 points, and these are the strict privacy regulations that we currently have here in Europe, by the regulator of this country. They told them it's not allowed to use any deep packet inspection for the user plane analytics. So you can analyze the user plane, but without DPI, which is of course somehow difficult topic, because if you want to know what has the customer been looking at when he had complained about the performance, and you cannot use DPI, yeah, it's difficult to get the service. Later on, you will see we still found some ways to still can track down at least the service that the customer was using at one point. And on the other point, we do that without using any user data which is above the layer 4 of an OSI layer model. So you will see later on, we are able to still detect services without using the deep packet inspection mechanisms. So this was all the starting point, all the prerequisites. Now, how did we solve all of that? We did it with the Omnia QM. So it's one of our newest solutions. So what is the Omnia QM? So the concept is we do a time window based metadata generation. You will see in the next slide what it really means. But what we provide is we provide a metadata record per subscriber, per application, per minute. So we already aggregating at the generation level of the metadata. We already do some aggregation that later on doesn't need to be done by a big data system. So we already offload a big data system. All of these records, because you use per subscriber, can then later on be enriched also by our tools with information from the control plane, for example, cell ID, radio access type, and all other information that can be queried from the control plane. That means in the end, the customer, our customer, will get the record for each subscriber. When exactly has the subscriber used a service like Netflix, and where has he been at this exact time? And with this information, you can then later on do all of their different use cases. So what are the advantages compared to others? This generation of metadata gives you a reduction of 1000 to 1. So that means if there's 1 terabit of input traffic, we will generate around 1 gigabit of metadata out of this traffic. The output in our case is completely customizable. So that means we have not a fixed set that always says you always get this and this information. This can be completely configured by the customer. Whatever they want to have in the record, we can put in. And then, as already mentioned previously, we have different options to do the service detection. We can, of course, use the classic DPI thing that has been done the last couple of years, but also with other methods which comply to the GDPR. So without using the DPI, and still you will get information about the used service. So what is time window based metadata generation? So the time window based metadata generation, on the left side here, and on the right side, classic one, flow based. So flow based is like a net flow, like all these flow based monitoring systems. And these systems worked good in the last years, but these days with this high data volume, they still can be used, of course, no doubt about that. But the problem is the amount of data which is generated by using a flow-based mechanism compared to ours is much higher. Because here in an example that you see, you have a client on your left side talking to an application here on the right side. You not only have like one connection, you will have multiple different flows. Yeah, the problem is in the most of the use cases, you're just interested in the client was using a specific application. You're not interested in all of these flows. Usually later on in an analytic system, all these flows will be combined or aggregated. On our side, we already do this aggregation process up front. That means if a client has multiple connections to the same service, in our case, it's just one record. So we already aggregating it. And like this, we are offloading all the systems which are behind our system. And this is the biggest difference compared to other solutions. Here's like such a solution would look like. Very high level overview. Usually we have a load balancing and filtering layer, like a packet broker, that will split the control plane traffic and the user plane traffic. And then from each one, we will generate CDRs. These CDRs will then be combined in an enrichment unit and correlation unit. And then from here, we can select whatever the customer wants in terms of output format, like Avro, CSV, JSON, whatever format is needed. And then send these, for example, to a Kafka server. And from the Kafka server, the customer queries it from the big data or whatever is here. But our solution basically stops here. So we generate all the metadata, and then the metadata can be transported to whatever tool is behind us. In terms of hardware, how such a solution would look like is, as said, in the beginning, we have a packet broker. Then this packet broker will separate the control plane here and the user plane here, send everything to a server. And on this server, we usually using here super microservers, is running our piece of software. This software is doing the correlation of these two CDR streams and then producing the metadata stream towards a Kafka system, for example. About the packet brokers, I mean, I guess most of you already know our lineup, so therefore still just a small recap. Usually in the mobile operators these days, you have high number of links and also high number of 100G links. So typically use is like a 32-100 for such a solution or even a 64-100. And most likely in future will be used as 32-400, which is a unit that has 32 ports of 400G. So this is typically the starting point. And then from there, we're generating the different CDRs. We have here our box, the EXA24400. This is doing the control plane CDR generation. So it has a protocol decoder and will decode the 3G, 4G, and 5G protocols. And we generate out of that information like session has started, what was the user IP address at this moment, the location information, all of that will be packed in one record and sent to this server. Similar thing is done on the user plane side. For the user plane, we have here our Omnia cards, which is kind of a smart NIC that has a CPU on it. And with this CPU, we are analyzing all the user plane and generating here the user plane records. So what was the IP address? What was the application used? So all the application detection is happening here. And then this metadata is also sent to a central unit. This is a central unit, is a server. And on this server, all the correlation and enrichment is handled. That means both of these streams coming to the piece of server, there's running our software, the correlation engine, and this correlation engine will correlate the two CDR streams and then do the Kafka stream, for example, generation or other different formats, whatever is needed, as said, CSV, JSON, Avro. So these are just things we already have implemented, but that's the key point. If there's some other output format that is needed, we are of course happy to adapt because this is what all this solution is about. It's about whatever customer needs. Yeah, we can implement in this platform. So about these challenges that we said in the beginning, of course, there's some solution to the challenges. And first challenge was it's not allowed to process any user data, especially above layer 5. So it's allowed to monitor the IP addresses. It's also allowed to monitor it was like the ports and then the protocols like TCP and UDP, but nothing above that. So this means with that information already not allowed to analyze, it's not possible to use the classic DPI engines that are available, because all of them are based on signatures, and the signatures use usually also higher layer protocols and higher layer information to detect the application. So this was not allowed. That means we needed to get some other idea on how to do it. First of all, we said, okay, then we will just not use the higher layer, we'll find some other methods. The regulator said, yeah, that's nice, but you somehow need to make sure it's not even possible that you can analyze it. Even if you say you will not do it, we don't believe you. So what we have done is we are doing the packet slicing. That means all the packets coming in looking like that will be cut after the TCP UDP header. That means the packet doesn't even have this information after the packet broker. So when the packet comes to the analytic platform, to the SmartNICs, all this payload is already removed. That means even if there would be running a DPI engine on the analytic system, it will not work because the payload already has been removed. So that's done already at the beginning. And then secondly, how did we manage then the service detection? As said, there's different methods, and all of these methods are available in the Omnia QM solution. All of them can even run in parallel. So whatever is needed at a specific customer case, we can just enable or disable. So there's the classic DPI engine. We have around 4,000 signatures. That's the one thing that usually everyone knows. But then there's IP lists. So what we have done in this particular case is the customer has, for specific services like Netflix, like YouTube, they have a cache server on site. That means if traffic goes to a specific IP address, and the IP address is their cache server, we already know exactly the application. So we don't need to use any DPI to detect this. So what we have done is we have like a kind of table where the customer can enter all of their on-premise cache servers. And if traffic goes to these cache servers, we will automatically detect the service, like they have in this example, Netflix, YouTube, and other big streaming operators or streaming vendors. And then, of course, this will only give you information on services that they have cache servers for. Usually, as a customer, you will not have cache server for all kind of different applications. So what we have done is we came up with the idea of analyzing the DNS. And how this works is we are getting all the DNS traffic out of this network. And then with clever mechanisms, we analyze this DNS and then try to build a connex between the used service or used domain and the IP address used. And like this, you can build up a table, which is of course not as good as a classic DPI engine. But what we have seen is even if you just use like 20 to 30 services where you do this DNS analytic for, you will get 80% of all the services. Because for this customer especially, they want to use what was the bandwidth for a certain service used at a certain time. And if 80% of all the services used can be detected by only like 30 services, then you don't need to use DPI. Of course, DPI will give you thousands of small services, but for this use case was not even relevant. So with these two approaches, we could already justify the customer, and even more important, we could justify or we could make the regulator happy, and that was the important thing in this case. So how the exact deployment looked like there is the customer, as said, has 2 data centers, and we are doing the packet slicing. Important in this case, so it can also look different, this solution, but these data centers are very close together. So what we did is we are like backhauling all the traffic. We already sliced the traffic in one data center and sent the whole user plane traffic across to a central analytic platform. This doesn't need to look like this. Of course, the whole solution can also be built per data center. And then in the end, only this metadata stream will be sent from each data center. So it's not needed that all of the traffic is always backhauled to a central site, because of course, as we know, this is typically only possible if the traffic is not that high. As you have seen there, traffic is there in total 1 terabit of traffic, which means it's only 500 gigabit of traffic per site. So it's not that much. And even if we do here the packet slicing, the traffic or the bandwidth used is even much smaller. So the interconnection between these two sites is only 2 times 100G, because as said, we are doing here the packet slicing, and the packets are only then after the slicing around 100 byte long. So here are some sample use cases that this customer is using. One I already told in the beginning. So what they do is, customer usually, they will call and say, my network performance, my download speed was not good or was very, very bad. So usually there's only two things that you can do: either believe the customer or you have some way to prove it. And with our records, of course, the customer or the operator in this case can easily prove if it was like that, because they just look in the records and they can just see, okay, at minute 30 or whatever, they had 180 megabit of download speed. Strange that they complained. So maybe it was a problem of the app or of the phone or whatsoever. So they can exactly monitor the performance that the customer really has had in the end. Also possible, now going away from the actual customers of the service provider, going to the service provider network itself. As we have information on the user plane traffic, but this is all enriched with the cell information, it's of course possible to do dashboards about each cell. So what was the performance from each cell? And like this, I can detect like trends. I can do my network planning and say, okay, in this and this region, maybe we do more sales, or there's some cell which is always flattening out at some period of time. Maybe there's some issue, things like that. So I can also monitor the network itself. And the third one, which this customer had, is they wanted to do a planning on their cache servers. As said at the beginning, also they have their cache server for like a Netflix, for YouTube, and so on, all the big streaming guys. And they needed some way to monitor how much traffic even is going in this direction. Because what we can do is we can then detect, for just take again this example of Netflix, as everyone knows it, like you have 100% Netflix traffic and only 20% is going to the cache server. Then they can call Netflix and tell them, look, guys, why is your cache server that you sold us not working so good? Because we expected maybe 80% of the traffic is going to the cache and not so much going via the internet. Because, of course, the customer is tended that as much information as possible is done on premise and not needs to be queried from the internet, because this will increase, of course, also the customer experience, as this is just much quicker than downloading, of course, all the information from the internet. So there was now one thing that you have not seen in all the records. I've talked now about you have records on what was the downloaded bytes, where has the customer been, all these kind of things, but there was one thing missing, and that is delay. And usually this is a question that we always get is, yeah, but I also want to see the delay, the round trip time that was at this exact time. So for this, we developed a separate solution that could also work, of course, in standalone or in addition to the Omnia QM. And this is the Omnia MA for measurement. So the Omnia MA is also a metadata generation platform, but it generates metadata for the delay. Okay. So again, because it's just built up on the same environment as the QM, what is possible is that we deliver records also for the location. So where has the customer been? What has he been doing? whatever has been streaming, and what was the delay at this exact time. So it's an additional information that could be used in terms of use cases. So how it works is we send only the three-way handshake packets to the analytic platform, because these packets we can filter out with our packet brokers that you have seen before, like this 32.100, 64.100, and 32.400. So this can all be done there in the chipset without using any CPU. Therefore, we can already reduce the amount of traffic that is sent to the analytic dramatically. Then we will analyze this communication, so the three-way handshake. And then what it gives us is the following, and the inner delay. So usually when you talk about the round trip time, there is the round trip time, if you have a client here, is measured this whole way. So from the client, from the end device to the server, whatever the server is, in the internet somewhere, and back. Yeah, there's one big problem usually, or one big problem that we see. And this is the problem that behind this point, this internet to the server point, the operator has no influence on that. Yeah, but the problem is that most of the delay introduced is at this part. So in the end, you get results, but these results are not meaningless, but you don't have any way to use it, because you don't know, is this server, if you're now a European customer, is this server in US or is this server in Asia? Because if the server is in a very far away, of course the overall delay will be very big. If the server is very close, overall delay will be very small. So therefore, there is not really any value in using this data. So what we have done is we have two different ways. We can do either the inner delay or the outer delay, as I said. So we call it now outer delay. So it's the delay between your tapping point and the server, or you take the inner delay between your device and the tapping point. We can provide both of this information, but of course, this is the information the operator want to have, because this is all that you can control. Of course, you cannot control the this delay here, but still you can control all from the inode P to the EPC, or to the tapping point. Let's call it tapping point here. So all this is under control. That means, again, as I can do the correlation between the location and the delay, I can see if there's some issues. For example, people always connected to the same inode B have a longer delay than others. This I could see in all the records. I can see that as more people, obviously, are connected to an inode B, as longer the delay will be here. So all these kind of things can be queried out of our data. So the message behind it is our data can provide a lot of information. It's just always the matter on how to use it. This is the whole thing about this solution, about the Omnia QM and the Omnia MA solution. Most important point is people behind it, they need to see the value of this data. And you see the value is there. There's an unlimited number of use cases. But of course, they need to be implemented. The data we can deliver. The use cases, they need to be delivered by the operator, because they know what they want, they know what they need. Here is, for example, how such an CDR in raw format would look like. So as said, this is now a CDR for the MA, so for the delay. You see the delay values, you see correlated insight, and the EMI and the IMSI and the APN and the location info, and all of that stuff in one record. So coming to the summary, one of these Omni cards that you have seen can do up to 50 gigabit of user plane analytics. In the server that you have seen, or usually typically in the housings that we are using, we can fit 8 of these cards. which will give you in a 4, or even here in the new ones 10. So this will give you 50 by 10 is like 500 gigabit of user plane traffic analytics in only 4 U rack space. And this is, of course, something that is very important, because we know people will install this kind of solution in racks that are already existing. Usually people will not build new data centers. So it's important that solutions are also slim and not using tons of rack space, because usually what means tons of rack space means also tons of energy consumption. Scalability in this solution is rather easy, because if there is more user plane traffic, you can see, you have seen these NIC cards are rather small, just more NIC cards are used. As said, we can load balance across multiple servers, or if there's multiple data centers, also this is not an issue at all, because we can do the analytic in each data center, and then in the end, combine the CDR stream or send the CDR stream from each of the data centers. Whatever is needed, all of these options are possible. We have a really good reduction from 1000 to 1. So if you have 1 terabit of user plane traffic, this will result typically in 1 gigabit per second CDR output. Our flexibility, we can customize exactly to what is needed by the customer. So we can really deliver a tailor-made solution based on the customer requirements. So example again, is DPI allowed? Yes and no. What information needs to be in the CDR or in the metadata stream in the end? What should be the output format? Should it be CSV or JSON or Avro or any other format? So all of these we can adapt to and deliver a solution that fits to the customer needs. And I said again, yeah, our low footprint already explained before. So with that, I would give back to Paul.
Yeah, thanks, Lucas. So if I just briefly summarize what we've covered, I think it was very interesting. So the customer, as I mentioned earlier, was one of the major mobile operators in Europe, and obviously what we delivered was a solution that allows them to cost effectively carry out their monitoring and analytics across multiple technology domains. And operationally, it helped them to increase revenue and customer retention, but I think also give them a platform for sustainable technology going forward. And at the same time, we were able to help them reduce their customer churn, because we were able to help them to manage their networks better and therefore increase their customer satisfaction. We were able to mitigate that challenge that we started with, if you like, which was they wanted to be able to reduce the rate at which they were having to continually invest in monitoring systems as their network traffic grows. And finally, we were able to reduce their costs, not only by addressing the CapEx and OpEx of the technology solution, but also by being able to reduce the other ancillary requirements of power, cooling, and space. So that sort of brings us to the conclusion of what we were going to cover today. I hope you found it worthwhile and interesting. We're going to move now to a Q&A session. So if you have any questions, please post them in the chat.
Yeah, I see here one that was asked is, how many services application does the customer monitor? In this particular case, they are monitoring currently 28 applications, because this was their key requirement. They said for that amount of use cases they use, it's not needed to use the DPI. Anyway, it wouldn't be allowed. But still, this is fine. And for example, they have applications, all the big streaming guys, but also other applications like Zoom, like Microsoft Teams, these kind of things. So all built towards customer satisfaction, because these are the important applications in terms of customer satisfaction these days, because these kind of things in terms of, for example, home office, these things need to work, and therefore they want to have a closer eye on the usage of these kind of services.
Actually, just one question that comes to mind that I have, Lucas. Were there any other use cases that were being considered for that our technology is enabled for the customer?
Yes, I mean, there's others considered also. For example, a very good point is one is checking about the roaming. Okay, so people usually they will travel, especially in Europe, where roaming doesn't cost too much. But still, this customer, for example, has own use cases. They will check about on the IMSI because the IMSI is included. Based on this IMSI, you know where the people are coming from, and then they will check how was the experience for people visiting your network, because that, of course, is also important that you can provide to your partners that you have. This was the service that we can guarantee, or this is the service that we can give to your clients, to your customers that coming and visit our network. Yes, so there's another question. Service and application could be customized according to the customer needs. Yes, absolutely yes. This can fully be customized. Can be 5, can be 10, can be 30. Whatever applications we can do without the DPI. Of course, in the end, it depends also on the effort that everyone wants to spend. So what we have seen currently in all the projects, we are working like 30, like 35. This is something that usually fits to most of the clients here in Europe with the use cases that they have. Of course, can be more, but there's always some maintenance behind to have all this DNS analytic still aligned and so on. So therefore, at a certain point, it doesn't make any sense anymore to go with the DNS approach. Then you again need the DPI. But if the DPI is not allowed, so you see, then in the end you will run a bit in circles. But to come back to the question, yes, it's possible to completely customize whatever services are needed.
Good. I hope that's answered your question, Sergio. I've just one last question, actually, Lucas, which I think would be quite interesting, because bearing in mind there wasn't really an easy solution to this problem. Actually, I'll tell you what, somebody else has asked a question, so I'll stop my question as we pick up this question from Ralph. So did the customer also analyze the IoT traffic?
Yes. So they're also looking currently into that. So it was not a specific requirement in the beginning, but as we are in constantly talks with them, this is something that they are now doing. They have for special IoT devices own APNs, own IMSIs, and with that one they filter it out and then do own use cases only for these IoT devices. Usually the control plane is maybe not so important for them because many IoT devices are rather stationary, but the user plane, this is what they are interested in, because everyone, of course, is interested in, are they talking, are they doing anything, whatever they do, this is what they want to do. Also for 5G, because this solution, as said, the customer, they have 5G standalone. Currently, the 5G standalone, they only are using the 5G standalone for these kind of modems that customer can buy at home, these SIM card modems. This is what they are using it for currently. So they have IoT only for the 4G or 5G NSA, let's say, not the SA. Then there was a question on the pricing. I guess that Paul can then in the end directly contact you and give you information on pricing of this solution.
Yeah, and there's another question there.
There is also a very good question. So if there's any tool to monitor this solution, because now we said, okay, we will generate CDRs, we will do whatever reduction. So of course, on top of all this whole solution, we have built a kind of monitoring, a GUI monitoring, where you can see this is the amount of input traffic, that is the amount of CDRs generated, that is the network performance for 4G, for 5G, so some very basic dashboards, let's say. So we have a monitoring system to make sure that all our solution is still running.
Okay, and we got another question.
Yes, so on the use case of XDR and DPI, you mentioned that you use slicing. What do you propose when customer needs to do analytics of all data? Yeah, so of course, if the customer want to use the DPI, then we will not use the packet slicing. We will use the full packet, and still the performance will be the same on the NIC card, because the NIC card performance is actually a packet per second limit, because it's a CPU running, and the CPU running don't care about the input gigabit. In fact, in the end, it's a packet per second limit, and the packet per second does stay the same if it's sliced or not. Will always be the same. Yeah, so per rack unit was also here a question, what is the performance? So depends on the, let's say, server chassis or the chassis that is used for the NIC cards. On the solutions that we have used is you have like a 4U chassis where you can put in the NIC cards, in the big ones up to 10. So that means 50 by 10 is like 500 gigabit of user plane traffic for 4U. Then you, of course, will also need a packet broker on top, maybe another U, maybe you have a 2U unit, so which will be like 6U. And then in the end, you also have the control plane probe, this EX824400. This is another U. So between 6 and 7U, you can do 500 gigabit in total with all the accessories included, like the packet broker and so on. But typically, customer maybe already has a packet broker. So in this solution, doesn't need to be our packet broker even. The only important thing is that the traffic comes to the analytic platform, and the user plane comes to these smart NICs, and the control plane comes to EX824400. Everything else is not important. But of course, we are very happy if the customer already has a packet broker from us, or will also purchase the packet broker for this kind of project. Next question. Is it possible to generate XDRs on one pin with DPI and then several points in the network, only outer and inner IP, to see which point in my network I have packet delay, packet loss in case of dynamic IP network, everything across connected to each other device? Yeah, this is a very good question, to be honest. If we again now think about how the design was looking like, is usually we only get the information from the tapping point. So if there's one central tapping point, I only have the view on this tapping point. But especially for delay cases, if I have multiple tapping points because they are across different network, of course this can work. And then we can take also this in consideration, that one tapping point is there and one tapping point is there. We can mark the information was coming from tapping point A and the other information was from tapping point B, and then correlate or analyze this delay information differently. So that would be possible. Can the system process also sliced traffic from different packet broker vendor? Yes. So, I mean, for us, it just don't matter where the traffic is coming from. It just needs to look like how we expect it. So in case of a mobile operator, needs to be GTP packet, and then the GTP packet, of course, needs to have a certain length. We currently use like 102 byte, could be 98 byte, whatever. So all these layer 3 and layer 4 information on the inner packet still needs to be present. That's the key requirement. And very detailed now, also VLAN tagging needs to be able on the packet broker. But yeah, I think that's a standard feature these days on all the packet brokers. What is the difference impact on performance solution between the DPI and DNS analysis? Yes, also a very good question. Of course, it's not the exact same performance, but what we have seen is we calculate with 50 gigabit per smart NIC, and this is a performance we can reach for both. In fact, it always depends on the exact services used, but 50 gigabit, this is what we can calculate for both the cases. That also will mean in case of only using DNS, it's even a bit more. So could be 55, could be 60 gigabit, but with 50, this is how we scale all these solutions, and this is what we have seen is working fine. Is the correlation server the same server as where the SmartNICs are installed? Yes, usually this is how we do it, because like this, we save rack space. I mean, there's two approaches. Either use just a cage, like these days may be popular mining rig, where you have like usually just GPUs in for crypto mining, stuff like that, because our NIC cards, they only need the electrical power from the server. Or if you want to save rack space, you take just a 4U high server, you can put in all the NIC cards, and then the NIC cards transport all the metadata to the server, which is in the same chassis. So like that, this is the reason why we do it. We just save rack space, not more than that. This was the idea behind it. So can be done like this, but don't need to be done like that. If DPI is needed, do we need to replace or add new hardware to the current solution? Yeah, in fact, not really. As said, the performance of the NIC cards are rather the same, so there's not much difference. And in terms of the server capacity, yeah, of course, more server hardware is more better. That's a classical approach, but yeah, there's not a real big difference in case of hardware. Of course, there's different licenses. For example, if you use the DPI, you need some DPI license on top, but this is rather detailed commercial discussions in the end.
Okay, I think those are all the questions. I guess unless there's any other final questions, I think we've pretty much completed our time. So thanks everybody for your time and attention. Hopefully it's been useful, and I hope you found the content interesting, and enjoy the rest of your day. Thank you.
Yeah, thank you very much. If there's more questions, of course, you can always reach out to us, and then we can also discuss off the records.